Alright guys, for this problem it says a railroad track and a road cross at right angles. So we have a road crossing and a railroad track that cross at a right angle. So there's my right angle. It says an observer stands on the road 50 feet south of the crossing. So there's the observer, and so he is 50 feet south of that railroad crossing. I'm just going to label this Y, so I'm going to say that Y is 50 feet. It says that a eastbound train is traveling at 40 feet per second. So it's traveling eastbound 40 feet per second traveling. So that would be the dx dt. So dx dt would be 40. Have no idea what the value of x is yet, but I probably can find it. It says at how many feet per second is the train moving away from the observer? Well, as the train is moving eastbound, the observer is standing still, so this would be the distance from the observer to the train. So let's call that dz dt. So that's what we're trying to find. Notice that dy dt is 0 because the observer is standing still. Now this last part says 3 seconds after it passes through the intersection. Well, 3 seconds after it passes through the intersection, and it's going 40 feet per second. So after the first second, it's moved 40 feet. After the second, it's moved 80 feet. Then after the third second, it's moved 120 feet. So this x value is 120. Well, we know what this leg of the hypotenuse is. We know what this leg of the hypotenuse is. So if we can find the hypotenuse, or the length of z, we'll be in good shape. So using Pythagorean theorem, we're going to do 120 squared plus 50 squared, and then take the square root of that. That's going to give me 130 feet. So the length of the hypotenuse is 130 feet. Okay, now we're going to write out the formula for this situation, which will be x squared plus y squared equals to z squared. So z squared. All right, now I could, since y is not changing, just go ahead and plug in 50 for y, but I'm just going to go ahead and do implicit differentiation and just go ahead and put 2x dx dt plus 2y dy dt equals 2z dz dt. Now keep in mind, we're trying to find dz dt. So let's plug in everything we know. We know that x is 120. We know that dx dt is 40. We know that y is 50. And we know that dy dt is 0 because it's not changing. And so that's equal to 2. And we know that z is 130. And then dz over dt. So that's what we're trying to find. We multiply this out. 2 times 120 times 40. That gives me 9,600. 2 times 50 times 0 is just 0. And 2 times 130 is 260. dz dt. 9,600 plus 0 is 9,600 equals 260 dz dt. Divide by 260, and then that's going to give me a final answer of approximately 36.9. And so that means that the train is moving away from the observer at approximately 36.9 feet per second.